So we need to determine if the following series converges or diverges, and if it's a convergent geometric or telescoping series, or can be written as one, provide what the series converges to. So to solve this problem, we will use the limit comparison test. Let's review what is the limit comparison test. So limit comparison test. So basically, if you have two series, two infinite series, the first one is, for example, a of n, the second one is b of n, then, and we have the limit where n approaches infinity, a of n over b of n equal to c. So if c is a finite and positive number, then both series converge or diverge together. So the series converge or diverge together. So let's see how we can apply this limit comparison test to solve our problem. So the given series, this one, let's copy it, paste. This will be our first series. A of n is equal to this. Let's just substitute case with n to make it easier. N. Okay, and the second series which we will use, b of n, is equal to the sum of 1 over n squared. Now let's calculate the limit where n approaches infinity, and we need to divide this by this. So we have n over n to the third power minus 17, and this whole thing is over 1 over n squared. Well, let's simplify our expression. So we will have n over n to the third times 1 minus 17 over n to the third, and this is multiplied by n squared over 1. Well, we will simplify this again. We see that we can just that our n's cancel, so n times n squared will be n to the third, and it cancels with n to the third here. So we will get limit of where n approaches infinity of 1 over 1 minus 17 over n cubed. And we see that because n approaches infinity, then 17 over n cubed will approach 0. So 17 over n cubed will approach 0. That means that 1 minus 17 over n cubed will approach 1, and 1 over 1 will give us 1. So we see that our limit here is a finite and positive number, which means that our series A converges or diverges together with series B. Now let's write down our series B again. So b of n is equal to the sum of 1 over n squared. We know that this is a convergent series. Which means that we will write down hence our initial series which was given to us is also convergent. Is convergent to. So to solve this problem, we used the limit comparison test, and we found another simple series which helped us to solve this problem using limit comparison test. And we proved that since the series that we used is convergent, and our initial series has to be convergent too.